Question 4, part 1, we're given this polynomial here, where a and b are constants, and we're told when p prime of x is divided by x plus 3, there's a remainder of negative 24. So just to the side here in this red box, I've written out the remainder theorem, which we're going to need to help us solve this problem. So the first thing we're going to do is we're going to find p prime of x. So working out p prime of x then, so we just need to differentiate p of x, and we can just use the power rule to do this. So for that first term, we've got 2 times x cubed, so then the indice is the 3. So 3 times 2 is 6, so we're going to have 6x, and we take 1 off the power, so we're going to have 6x squared. And then the second term will be 2ax, and the third term is plus b. And the constant term, minus 49, well, the derivative of any constant term is just 0. So we've found p prime of x, and now we'll use our remainder theorem to show that 6a minus b is equal to 78. So if we divide a polynomial by a linear factor x minus c, then the remainder is p of c. So we know that the remainder is minus 24, and for our problem we've got x plus 3, so that means our c in that formula there is equal to negative 3. So if we find then p prime of negative 3, well, that's going to be equal to 6 times negative 3 all squared plus 2 times a times negative 3 plus b, and we know that this is going to be equal to negative 24 because our p of c is the remainder, which is for our problem the p prime of negative 3, and we know our remainder is negative 24. So now simplifying this, 6 times negative 3 all squared, that's same as 6 times 9, which is 54. And then 2a times negative 3 is negative 6a, so minus 6a, and then plus b is going to be equal to negative 24. So just rearranging this, we'll take the negative 24 to the left-hand side, and then the minus 6a plus b to the right-hand side. So then we're going to get 78 is equal to 6a minus b. So that's actually our answer. I'll just write it out the same way they've got it in the question there. So that's the same as just 6a minus b is equal to 78. So we have shown then what we needed to show for question 4a part 1. So for part 2, we're given that 2x minus 1 is a factor of p of x, and we need to find the value of a and b. So I've just written out in this box over here the remainder theorem. So if ax plus b is the linear factor of a polynomial, p of x, then p of negative b over a is going to be equal to 0. So we've got 2x minus 1, so that means our a would be equal to 2, and our b is going to be equal to negative 1. So we are going to try and find then p of negative 1 over 2, which is just p of a half, and that's going to be equal to 0. So writing this out then, we get p of a half, p of 1 over 2, that is going to be equal to 2 times 1 over 2 all cubed, plus a times 1 over 2 all squared, plus b times 1 over 2 minus 49, and we set that equal to 0. So simplifying this a bit, well, 2 times 1 over 2 all cubed, that is 2 over 8, and then plus, well, a times 1 over 2 all squared is a over 4, and then plus b over 2 minus 49 is equal to 0. So we can simplify this even more. If we multiply through by 4, well then for the first term we get 4 times 2 over 8, which is 8 over 8, and that is just 1. And then plus or a over 4 times 4 is just a, plus, or b over 2 times 4 is 4b over 2, which is 2b, and then 49 times 4 is 196, so we get minus 196, and that is equal to 0. Now just tidying this up a bit, we're going to get a plus 2b is equal to 196 minus 1, so therefore a plus 2b is equal to 195. So we're trying to find the value of a and b, and now I've got two equations and two unknowns. So we'll call this one number 1 from part 1, 6a minus b is equal to 78, and the one we just found, we'll call that equation 2, a plus 2b is equal to 195. So we'll go about solving these simultaneously. So we've got 6a minus b is equal to 78, so that's equation 1, and then we've got a plus 2b is equal to 195, and we'll call that equation 2. So we'll multiply equation 1 through by 2, then add the two equations together, and then that will eliminate b. So multiplying equation 1 through by 2, so 6a times 2 is 12a, then for the rest we're going to get minus 2b is equal to, well, 2 times 78 is 156, and equation 2 is the same, so that's a plus 2b is equal to 195. So now adding these equations together, we're going to get 13a, so minus 2b plus 2b, 0b, that was the whole point, is equal to, well, 156 plus 195, that is 351. So a is going to be equal to 351 divided by 13, which is equal to 27. So now we'll substitute this value of a into, we'll choose equation 2, because that's going to be easier, because the coefficient of a is just 1 for that one. So substituting into equation 2, we're going to get 27 plus 2b is equal to 195. So that implies then that 2b, well, that's going to be equal 195 minus 27, which is equal to 168. So therefore b is equal to 168 divided by 2, and that is equal to 84. So our answer then for question 4 part 2 is we've got a is going to be equal to 27 and b is equal to 84. For question 4 part 3, we need to write p of x in the form 2x minus 1, all in brackets, times q of x, and q of x is a quadratic factor. So up here in the red, I've written p of x out with our values for a and b that we found in part 2. So we're going to solve this problem in two ways. The first way is we're going to just do it by inspection. So we know p of x is going to be equal to 2x minus 1 times some quadratic factor. So if we look at our constant term here, this minus 49, and this part here, this minus 1, we know we're going to have minus 1 times something to equal minus 49, and that is going to be plus 49. And then for this 2x cubed part, so we're going to need 2x times something to equal 2x cubed, so it's going to be x squared. And now if we look at our x part here, because we're going to need to fill x squared plus something times x plus 49 to finish off our quadratic factor there. So if we look at that x part, this 84x, then if we have 2x times 49, well, that's going to equal 98x, and then we're going to have to take away 14x to get to 84x. So then we need this negative 1 times something to equal negative 14x. So that is just going to be positive 14x. Okay, so that is our quadratic factor. So if I just write it out neatly, it's going to be 2x minus 1 times x squared plus 14x plus 49. Now the other way we could have done this is to use algebraic long division. So we'll have a go at doing it that way. So we know our p of x, well, that was 2x cubed plus 27x squared plus 84x minus 49. Now we know 2x minus 1 is a factor, so if we divide this by 2x minus 1, then we can find out our quadratic factor. So just thinking, how many times does this 2x go into the 2x cubed? Well, it goes in x squared times, because 2x times x squared is 2x cubed. So now we just go x squared times our 2x, which is 2x cubed, and then x squared times minus 1, which is minus x squared. So now subtracting that second line that we've got there from the first line, well, 2x cubed minus 2x cubed is just 0, and 27x squared minus x squared is 28x squared, and the others just remain the same. Okay, and then we think, well, how many times does 2x go into 28x squared? Well, we'll go in 14x times, and then 14x times 2x is 28x squared, and then 14x times negative 1 is negative 14x, and just subtracting again, so 28x squared minus 28x squared is just 0, 84x minus 14x is 98x, and then just bringing that minus 49 down. Okay, and finally, well, 2x goes into 98x 49 times, so that's plus 49, and then 49 times 2x is 98x, and 49 times negative 1 is negative 49, so 98x minus 98x is 0, and minus 49 minus 49 is 0, which is what we expected because we know that 2x minus 1 is a factor. So we're left up here with our quadratic factor. So therefore, p of x is equal to 2x minus 1 times x squared plus 14x plus 49. Okay, so it's a little bit longer sometimes doing that algebraic long division, but this way will always work, especially if you're having trouble doing it by inspection, if you can't quite see how it works out just by looking at it. Okay, so now we'll move on to part 4. So for part 4 then, we have to factorize p of x completely. So we know that p of x, well, it's going to be equal to 2x minus 1 times that quadratic factor, which I'll just highlight here in yellow, that we found in part 3. So we just need to factorize that x squared plus 14x plus 49 completely, and well, x squared plus 14x plus 49, that factorizes to x plus 7 all squared. Okay, so that finishes question 4.